The Antonio Project present automation unboxing decade resistant box and how to use.
Hello everybody, see you back in my channel. As you can see, in front of me, I have a lot of toys. What kind of toys are they? They are an engineer toys. In this occasion, I will share to you about decade resistant box. A decade resistant box, or simply called resistant box, is a combination of high accuracy resistors that are arranged inside of this box that form a set of resistance range, which is increased incrementally, mostly in a decade step or 10 steps. I have three kind of model resistant box. This one maker is Time Electronic. The range is 1 ohm to 10 mega ohm. This one also same maker, Time Electronic, but with different range. The range is 0.01 to 100 kilo ohm. This one is little bit different because the maker is Yokogawa, and then the range is 1 ohm to 100 kilo ohm. What are the use of this decade resistant box? This decade resistant box can be used to calibrate an RTD transmitter, like this RTD transmitter. Then to calibrate insulation tester, to calibrate resistivity meter, to verify or calibrate a simple ohmmeter or multimeter. And then other is to calibrate a conductivity meter. How to use this decade resistant box? Let's check out following video. Let's go.
Decade resistant box overview and how to reading the value. A decade resistant box is a handy tool for electricians or engineers. It allows to measure the resistance of various electrical components and create different resistances for multiple purposes. Following are few models of resistant box. This model made by Time Electronics with range from 0.01 ohm to 100 kilo ohm. Next model, the maker is also Time Electronics with range from 1 ohm to 10 mega ohm. Other makers is Yokogawa with range 1 ohm to 100 kilo ohm. Resistance scale located below the numbering of resistance box. Rotary selector switch located on the middle of resistance box. It is used for selecting resistance value as per required. There are 8 selector switches, where each switch having 10 numbers from 0 to 9. When first row of selector switch scroll to number 7, it means that the value is 7 multiplied with scale 0.01 ohm. equal to 0.07 ohm. When next selector switch scroll to number 8, the value is equal to 0.8 ohm. To read resistance box value in every selected number on the selector switch to be multiplied with scale below the selected number. Currently, the value of the resistance box is 374 kilo 776.87 ohm. For Yokogawa resistance box, to read the value, the selected number to be multiplied with the scale located above selector switch. At current, the value is 225 kilo 537 ohm. Connection of resistance box to temperature controller. Decade resistance boxes are commonly used for RTD PT100 or PT1000 simulation to calibrate RTD transmitters and resistance temperature devices. Following is how to connect the cables from resistance box to temperature controller. Prepare at least 2 or 3 pieces extension cables. Then plug in the male plug or banana plug to resistance box terminal female plug. Check temperature controller wiring. Make sure the type of RTD sensor, whether PT100 or PT1000 type. Also, RTD terminal number, whether it is using 2, 3 or 4 wires. Commonly, RTD sensors using 3 lead wires. This makes 3-wire RTDs more accurate than their 2-wire counterparts, but less accurate than 4-wire configuration. Make sure during connection to cables marked with variable resistance symbol connected to the terminal cable with the same symbol for temperature controller and resistance box. Disconnect 3 cables from RTD sensor, which is under questioning its working performance. Don't forget the marking on the cables by its colors or by numbering. Then connect the cables which has been disconnected from RTD sensor to resistance box extension cables with same order as the cable color code and the variable resistor symbol marked on the resistance box. When cables connection has been set up, you can start to carry out troubleshooting. Resistance and temperature conversion. I have created an automatic compensator calculator program to calculate conversion between temperature to resistance in Excel, and you can download the calculator freely. Please find the download link below on the description. To use this calculator, you can just simply click the up or down arrow to select the desired temperature, or you can select manual input column and type the desired temperature. Also, you can select from drop-down list the type of sensor, whether PT100 or 1000. I have compared the result of this calculator, and the result is matching with DIN IAC 751 temperature resistant table for platinum sensor. Troubleshooting of freshwater generator heating temperature fluctuation. On board of a vessel, there are many of system control are using PT100 RTD sensor for temperature controlling. RTD sensor picking up the measured temperature by converting temperature to ohm. Then the signal being sent to temperature controller to be converted to milliampere. Milliampere signal then being sent to positioner, where the milliampere signal then converted to air pressure to regulate control valve opening or closing. This is 3-lead PT100 RTD sensor for picking up temperature from piping system. Temperature then converted to ohm. PT100 meaning is the sensor made from platinum and the resistance 100 ohm equal to temperature 0 degrees Celsius. Temperature controller to convert signal from ohm to DC milliampere, then calculate and setting up the output based on setting value. Pressure regulator to regulate input pressure of control air. Temperature control valve consists of positioner to convert DC milliampere signal to pressure, actuator to operate the valve for opening and closing by air pressure sent from positioner, and valve to regulate amount of incoming fluid, gas, or steam. Steam boosting heater as heat transfer place from steam to fresh water. Steam boosting heater pump to circulate heated water from steam boosting heater to freshwater generator. This freshwater generator PID showing the automation of freshwater generator jacket water heating system. Jacket water heating is a closed system and temperature to be maintained about 85 degrees Celsius by temperature control valve. Heat transfer takes place at two locations. On the steam boosting heater to increase jacket water temperature and freshwater generator heating chamber to evaporate seawater. In case temperature control system fail, freshwater production will decrease. Therefore, it is necessary to carry out troubleshooting when fluctuation of heated jacket water temperature occur. RTD sensor pick up temperature from piping line and convert it to resistance. Resistance signal received by temperature controller and converted to DC milliampere. Signal is continuously transferred from sensor to temperature controller. Once something wrong with RTD sensor, then it will influence others. Therefore, sensor is the first priority to be investigated when abnormal condition occur in control system. Temperature controller is the brain of the control system. It is receiving input, calculating and processing the signal to desired control output. As you can see on the display, the temperature is fluctuated, range from 73 degrees Celsius to 90 degrees Celsius. Meanwhile, the setting value is 85 degrees Celsius. This condition considered under abnormal. Investigation will be started with RTD sensor. If the sensor is under good condition, next step is positioner and then control valve to be checked. In order to check the condition of RTD sensor, it is required decade resistance box to give dummy resistance signal to temperature controller. Set up resistance box as previous step, then scroll selector switch to set up temperature as per the required. When the resistance box set to 131.66 ohm, temperature indicate 82 degrees Celsius. When resistance increase to 132.80 ohm, temperature indicate 85 degrees Celsius. It means that correct value is received by temperature controller. Next step is reducing setting value or SP to 83 degrees Celsius, below the output 85 degrees Celsius to find response from control valve. Observe that control valve is closing. It means that control valve response is correct. Next, increasing setting value to 88 degrees Celsius above output 85 degrees Celsius. Control valve is opening, giving good response. Next step is returning setting value to 85 degrees Celsius as same as the output 85 degrees Celsius. The control valve closing until about 50%. In this condition, temperature control valve considered under good condition. It means that the trouble caused by malfunction of RTD sensor. Actual troubleshooting of freshwater generator jacket water temperature fluctuation. Preparation of decade resistant box. Disconnection of RTD sensor cables. Setting resistance value to resistance box. Checking the value on the temperature controller. Operation of setting value or SV by increasing and decreasing. Confirmation of control valve using 4 to 20 mA DC signal injection. After the investigation completed, found that RTD sensor defected and necessary to be renewed. I think that's all my video about leakage resistant bulb. If you have any question or advice, please write on the comment down below. Thank you for watching my video. If you think that my video is useful, please click like and subscribe button. Your contribution by subscribing my channel is highly appreciated. Surely, it will giving additional force to run up my channel engine. See you in my another video. Thank you and bye-bye. The Antonium Project.